Okay, so let's look at number 14. The midpoint of QR is M, and there's that key word, midpoint, is 1, 5. One endpoint is here. Find the coordinates of the other endpoint. So this is different. This is the one where I showed you the stack in class. So R is at 7, 4. Okay. And M is at 1, 5. So the question is, where's Q? On the previous question, we found the midpoint. We took the two endpoints, added them, took the average to get the midpoint. Now, if I were to take this out and look at it this way, I've got Q here, I've got M here, and I've got R here, okay? R is at 7, 4, M is at 1, 5, and we know these are congruent, they're equal. Where's Q? Now, the way I showed you how to do it is the stack, so we're gonna do the stack. All right, so we're gonna start with R, M, and finish at Q. Okay. So we know R 7, 4. We know M is 1, 5. So the question is, where is Q? Well, let's look at some distances. How did I get from R to M? Remember, if M is in the middle, then I have to do the same thing to get from M to R as I do from M to Q. How far is R from M? 6, right? Basically, I subtracted 6 to get from R to M, right? So what would I do to get from M to Q? I would subtract 6 again. So 1 minus 6 is -5. So that's where the x-coordinate of Q is. So let's do the y-coordinates. How did I get from 4 to 5? I added 1. How do I get from 5 to Q then? I got to add 1 again. What's 5 plus 1? 6. There you go. Now, some people will teach you to set this up algebraically. Meaning, what do we know about, for example, the x part of the midpoint? x1 plus x2 divided by 2 gives you your x-coordinate for your midpoint, right? The x-coordinate for my midpoint is 1. My x1 is 7. I don't know my x2 divided by 2, and then you can solve it that way, which you would put 1 over 1, you would cross multiply, you would get 7 plus x equals 2, then you do the subtraction, and what do you get? -5. Same way. I think this way is harder. Personally, I like this way better. Okay? All right, so let's look at 15. The figure shown, AED, is 116. Remember, the vertex is in the middle. AED is 116. True or false? AEB and AED are adjacent angles. Okay. AEB. Here's AEB. Okay. AED. A to E to D. First of all, are those adjacent angles? Yes, they are. They share a side. What side do they share? They share AE. Okay, they share AE. Do they share a vertex? Yes, they share E. They share that vertex. So they are adjacent. So the question is, are adjacent angles, and the measure of AEB is 64. So is this 64? Well, what kind of angles are those two adjacent guys? That's a linear pair. Our two adjacent angles here, this guy and this guy, they make a linear pair. What do linear pairs add up to? Their sum is 180. So I'm going to take 180 and I'm going to subtract the 64. Sorry, not 64. 116. Sorry, that's what happens. Subtract the 116 and I'm going to get 64, which is correct. So the answer is true. They're adjacent. And because they are adjacent and they make a straight line, they're supplementary, which means they're a linear pair, which means they're supplementary. So I subtract this from this. So there's your answer. Okay, let's look at 16. 16 in the figure shown, AED is 114. Excuse me. So this angle right here, AED, vertex is E, is 114. CED and AED are adjacent. Okay. Here's CED. CED and AED, yes, they are adjacent. They both share side ED, and they both share vertex E, okay? Now, is CED 66? Okay, well again, what kind of angle pair is this? These two adjacent guys make a straight line, so once again, we've got a linear pair. And a linear pair by definition is two adjacent supplementary angles, so they add to 180. So I'm going to take the 180, I'm going to subtract the 114, and I'm going to get 66. So the answer is yes. Okay? All right, so let's look at 17. Number 17, OR and OP are opposite rays. This one's kind of tough, all right? So I've got OR, and then I've got its opposite buddy going this way, OP, and they're opposite rays. OQ bisects TOR. So you kind of have to figure out where Q and T go, all right? So what I'm going to do is I'm going to create TOR first. I'm going to put a point T. I'm going to put a point T. And then what does it say about OQ? OQ bisects. What does bisect mean? Cut in half. Two equal pieces. So ray OQ is going to bisect angle TOR. So I'm going to put OQ right there, and it cuts this angle in half. Does everybody understand that? Again, I put the T out there first. We don't know where it is. We're just kind of giving a random guess. The measure of TOQ, remember O is your vertex, TOQ is 41 degrees. Draw and sketch and find TOP. So I want this angle right here. And a lot of people struggled on this in class. So 41, well, if OQ is a bisector, if that's 41, what's this guy? It's also 41, because OQ is bisecting the angle. Okay, so I've got two of the three angles. And here's our favorite thing. These three guys form a straight line, right? So that is not a linear pair, because remember, a linear pair is if you've got two angles that form a straight line. It's two adjacent supplementary angles. We don't have a linear pair here. But any three angles, four angles, five angles, any group of angles that creates a straight line will add up to 180 degrees, okay? So let's look at what we have. We've got 41 and 41. We've got 41 and 41. We're looking for that guy. We know 180 minus this 41 minus that 41, or if you wanted to add them together, minus 82, equals my missing angle. So 180 minus 82 would be 98 degrees, just like the musical group. Nick Lachey. You guys probably have no idea who that is. So you've got 180 minus 82 gives you 98 degrees. That's your angle.